Dr. Cheng Wang, the time is yours.
Hey, good afternoon, everybody. My name is Cheng Wang from Amazon Web Service, Singapore. So before I start my presentation, can I have a very, very quick survey here? Can I know how many of you knows Amazon Web Service? Okay, probably 50%. And how many of you are working with Amazon Web Service or using Amazon Web Service? Okay, no setback. Yeah, just very quick information about Amazon Web Service, because when I walk around, have some conversations with our customers, audience, many people know Amazon.com. Yeah, include myself. I spent quite a lot of money on Black Friday. But not many of the guys knows Amazon Web Service. Actually, Amazon Web Service starts from 2006. Right now, Amazon.com, the retail service is fully running on Amazon Web Service. So Amazon Web Service is the data center, including all the services that's supporting Amazon.com, the retail arm. So by 2024, Amazon Web Service, AWS in short, will have about 125 data center over 35 regions by 2024. And we launched the CGK region in 2021. So we do have a local region. Each region of AWS has basically minimum three available zones. So each available zone is a data center here. So we have at least 3 data center in CGK region here. About 2025, Amazon Web Service will become a company use 100% of renewable energy. And by 2022, 70% of our electricity consumption is from renewable. So that is basically a very simple introduction of AWS. So now let's start the digital twin here. Let's see how to use that. Excuse me, okay, next. So optimization of operation with scalable digital twin. And here the keywords is scalable. So by the end of this presentation, if you forget everything I taught, so please just remember one keyword, scalable. So regarding of the digital twin, I will start from the challenges to build a digital twin. I know many people start digital twin or digitalization journey from long time ago, probably 5 or even 8 years ago. But 60 or 70% of that digitalization failed. I think that number also applicable to digital twin. Many of digital twin initiatives end with nothing. Then the next is about digital twin framework and IoT twin maker. That is one of our 200 plus services you can find on AWS panel. Then some successful use cases for you to get some feeling of how to utilize digital twin, how to implement digital twin on AWS. And the last one is, if the whole message is of you interesting and you are wondering how to start this journey, so how do we start? So what about digital twin? What's the definition of digital twin? Different customer has different definition. And here is AWS definition. I'm not going to argue with any other customers of vendors about the definition. I just simply say this is our definition here. So for a digital twin, there must be 4 components here. The number one is there must be a physical system. When you come to the manufacturing, the physical system means the equipment, robot, a production line, or even the human workers, or even the factory buildings. So all of these are the examples of the physical system that existing in the real world. So by this definition, the metaverse or game we don't consider them as a digital twin, okay? Then the second element is the models here. Many of the smart manufacturing start from 3D models of the equipment of the buildings. So it can be a 3D equipment model. It can be a process simulation of your production line. It can be an entity like human behavior. It can be a robot behavior. So all of these models either is a 3D visualization model, is a simulation, behavior simulation model. The key here is there must be a model behind. There must be a model behind from AWS framework or definition. Then the next component is the connectivity between the real world and that model. So taking a smart building as example. So many people say a very sexy, fancy 3D model of the building, right? And when you connect the IoT sensors or PLC or DCS or whatever, the data from the field measurement to that 3D model, you get that connectivity. And on the 3D models, you can display the dashboard, the measurements, air quality, the temperature, whatever. And the last component, which is the most critical component for us, is why are we doing all of this, right? I can have a fancy smart building 3D models with all the data displaying on top, but there must be a business outcome. There must be a business outcome. The management, the CEO, CIO, CFO will ask you, why do I invest $1 million in this digital twin, and what is my ROI? So this actually start the conversation. Whenever we get some discussion with our customer who is interested in the digital twin, our first question is always, why? Why do you need a digital twin? On smart building, on smart manufacturing. So what is the ROI? What is the outcome you expect from that digital twin? So this outcome will drive the discussion about use case, about the scope, about what to be implemented in digital twin. And that discussion is supported by, let me skip some slides because it's really a very heavy content here. So to drive or continue that discussion of the business case or digital twin, we categorize all the digital twin use cases into 4 different categories. The reason is the framework doesn't mean step by step you have to do L1 followed by L2 followed by L3 followed by L4. So this framework is more like a facilitating the discussion. Look at what exactly the outcome you expect from the digital twin. If that fall in one of these 4 categories, then we can leverage on similar use cases to continue that discussion, to drill down to the technical details. And you see what other customers is doing, what is the ROI, the outcome from that use case, and whether that's applicable to you or not, and what is the services to support that use case. So we have 4 categories here. One is L1. We call it L1 descriptive. A very typical example is a smart digital twin before the building is in operation. Right? You have a 3D BIM model, you have a 4D BIM model. Start from the design of the building. The people has to evaluate, right, the impact of this building to the traffic, to the environment, and the noise level of this building, and how I can build a building with the most energy efficiency design. So all of this will be done by several vendors, the design consulting firms. So they will build 3D models, all the designs, before the building put in the operation. So all of this we call offline design for engineering purpose. And by the end of this L1 digital twin, you have a full-fledged of BIM model, right? You hand over to your end user. So L2 informative digital twin is more like connecting the measurement with all these models. Either it's a 3D model or 2D model, it doesn't matter. A typical example is smart manufacturing. For example, you have food and beverage, right? You want to collect all the data from either your PLC, DCS, Modbus, IoT sensors, and you want to link those data to your dashboard. And the dashboard itself is 2D or 3D, it doesn't matter from my point of view, right? So the challenge here is how do you connect all these things to your dashboard with different communication protocol, and some of the windows doesn't open interface to you. But by the end of this digital twin journey, you will get all the connectivities, you will get the data displayed on the dashboard. And those dashboard is used for the manufacturing manager, utility manager to make their decision with all the data supporting his decision. So we call it L2 informative digital twin. And once you finish this L2 digital twin, the utility manager probably is looking for something smarter, right? Rather than look at the efficiency of chiller and manually justify what could be the root cause of the low efficiency, you hope this dashboard, this platform, has kind of intelligence. If the room temperature is too low, or if the chiller efficiency is too low, probably you want this dashboard to tell you, or this digital twin to tell you what is wrong. What could be the root cause of the low efficiency, right? So the dashboard must be able to provide insights based on some model. So here we call predictive digital twin. This digital twin is able to predict the behavior of your equipment for predictive maintenance. It can tell you what is the variable that unmeasured from your sensor. For example, for a chemical plant, probably you take your lab sample every shift. So every 8 hours, you have a quality data. But within that 8 hours, to realize the optimization, automation, whatever, the strategy, you hope you have a continuous measurement of your quality, and which is not possible with your lab data or online analyzer. So in this case, a digital twin should be able to tell you the continuous quality measurement by some inferential model. Right, that is so-called predictive digital twin. Again, let's take this chemical plant as example. Once you build an inferential model, right, probably you have, let's say, a few hundred, even up to 1,000 inferential model for a chemical process. Once you build that model, without a proper maintenance, I guarantee 3 months later, your model prediction will be deviating from your laboratory data. Very soon, your prediction from that model will become inaccurate and no longer possible to use that data to control or optimize your chemical process. So to maintain that model, normally, traditionally, you need a team dedicated to verify the data against your laboratory, against your analyzers, and keep that model updated manually by using some algorithm on your laptop or computers. So L4 digital twin, from AWS point of view, is how to make this process more efficient, automated, and minimize your in-house efforts to keep those models up to date. So by the end, you get a living digital twin that is really a miracle of your life system. No matter it's 3 months, 6 months, or 12 months later, your simulation of predicted value is still aligned with your real process measurement or laboratory data, right? So these are 4 different categories we define a digital twin. And you can look at this framework and look at your own use case, which purpose that you want to achieve at this moment with your current situation. If you are looking for a L2 digital twin, probably the discussion will continue with IoT team, how to deploy the IoT sensors, how to get connected, right? And how to create a meaningful dashboard to support your decision maker. And if you have already done some of the L2 digital twin and you are looking for more intelligent predictive functions, so that will come to L3 or L4. So depending on what is your use case, we can continue that discussion so we drill down on each category and what is the service AWS can support you. So the orange color are all the services that are running on AWS cloud that you can leverage on them to create your own digital twin based on what is the outcome you expect, right? I won't go through all of them. It will take probably another one day. Just concentrate on two services today. One is called Twin Maker. Another one is called Do PM Framework for L4 Digital Twin. So that are the two services I'm going to concentrate on in this presentation. So this is Twin Maker. So before I explain the details, I want to highlight another point. Every digital twin, no matter you are doing L1, L2, L3, or L4, itself is a journey. Just because digital twin is not a boxed product. You can't buy a digital twin from the market for your own process. Every digital twin is a journey of putting all the technologies into one piece of digital twin, right? So by using a twin maker, it doesn't mean I buy a twin maker service here, tomorrow I can put it online. So digital twin, or twin maker here has, from my point of view, it has two biggest advantage along this journey. Number one, when you make a twin maker here, the first step along the journey, it helps you to pull all the data from different data sources. That is part of your twin maker journey, right? So if I raise a project, if I request a project to my top management, I say I want to make a twin maker here. So probably you can leverage on this digital twin project to consolidate all your data from different data sources. Right? Twin maker basically provides rich API or interface to connect with different data sources. You don't have to pull all the data from different data sources into a centralized data lake. You can still leave all the data at where it is now. And just pull the necessary data by using like IoT Core, IoT StackWise, those kind of IoT service running on AWS to pulling the data. And on Twin Maker, we also have a visualization function. We support GLTF 3D asset format. So GLTF stands for Graphic Language Transmission Format. That is kind of a 3D asset format. We can import all this 3D format data and make a 3D visualization. So we have 3D models running here. We have all the data from different data sources here. And the back end, you can see, this demo. So this is a food factory. So you can see all the equipment, you can move them, put them in the different locations. You can navigate through the production line. And you have the video streaming data if you want to zoom in certain area of your factory. And on top, you can see some KPI for certain equipment here. Yeah. So this is another demo here. Oh, sorry. Why it doesn't play? Sorry, just I think the video is not working here. I don't know why. Yeah, so maybe I will come back to this video. What was not showing in this video, but in the next video is on each equipment, you can see the blue dot over there. That is actually a measurement. So on each equipment, you can see the real-time measurement of the efficiency, the temperature, vibration, all these signals on this 3D visualization panel. So actually the next demo, if I complete a video, within that demo you can see for every plant we have a knowledge graph. A knowledge graph showing, okay, it's running here. So this is a TwinMaker demo. It's basically a utility management. So on this map, you see the different buildings worldwide. Supposing you are running a global manufacturing group, you want to zoom in a certain building here with a pre-fixed camera. Then you can see the building outside and inside in real time. Yeah, this is the camera view. And there's an alert over there. It's showing some temperature is too high or too low. So you can click that alert and zoom in the knowledge graph. Then you can find, actually it's on this part. The knowledge graph is showing all the black. You cannot see. But actually, in the knowledge graph, you can see the connection among different equipment, different variables. So from that alert, you can see what is the root cause that connected to that alert. Then you can trace back and find out what is the root cause from that knowledge graph. So for utility manager, you are not only getting the alert, but you can identify the root cause from that tree, or root cause tree, some people call it. So our TwinMaker service is the AWS service that you can connect the 3D model by importing that GLTF format file, translate that into a 3D visualization panel. You can also leverage on the IoT core, IoT set-wise to connect with your IoT sensor, your PLC interface, Modbus, DCS, OPC, UA, collecting all the data and the display on the 3D models here, the dashboard here. And also you can create your own KPI, which makes sense to you, and put on the 3D dashboard. And you can also zoom in the alert to a certain equipment and identify the root cause from the knowledge graph. So that is how we use this TwinMaker, what it can do. So this is a use case we have done together with Invista. So Invista is a subsidiary of Coach Industry. It's a leading global manufacturing of fiber, resin, and chemical. And they are using our TwinMaker to create a so-called single choose by connecting all the sensors and the database inside their plant. So here, to remove the silo amount of data, TwinMaker had to connect the existing IoT sensor as well as their existing OSI Pi data. I think many of the manufacturing and chemical process, you are using OSI Pi as a process-based storage. But when you add new sensors, right, it will be troublesome to add that new sensor to your PLC, SCADA, and connect there to your OSI Pi. So easier way is, why don't I just leverage on MQTT or whatever, LoRaWAN, and transfer that data to my cloud. So on the cloud, you have IoT data, you have your existing, for example, OSI Pi data. Then easily you can remove the silo between these two data sets. So the impact from this project, you can see on the right-hand side is improve the productivity and the efficiency in field operation. EHS performance improvement, and further opportunities to use employee expertise in finding new and better ways to create value for the customer. So Twin Maker or L2 digital twin provide you, number one, the connectivity. The data silo removed from all different data sources. And that data can be fed into human intelligence or artificial intelligence. So that will be the next step of your project, probably. So this is our partner about Twin Maker. So AWS customer come from two different main categories. One is we have customers that has a very strong in-house technical capability. They want to build their own solution because they know their process better than anybody else. So for those customers, we call them builder. So AWS will enable our customer technical team, teach them how to use all these services, and the customer in-house technical team can build their own solution. The second category of the customer is they probably just concentrate on their core value, and they don't want to spend a big effort on developing the solutions, deploy the solutions, and maintain the digitalization solutions. So in that case, we will introduce our partner who can build the solution for our customer into the team. So these are the partners that they can help our customer. These are the partners that they can help our customer to build solutions on top of AWS. So different ecosystem, different approach to realize your digital twin. So I just want to highlight the next one is the L4 digital twin. Okay, I will speed up. So once we have L2 and L3 digital twin, I want to keep that model alive. I have to minimize the effort for customer to maintain that model. So the key point here is the probabilistic modeling here. Let me use this as example. So for example, as a manufacturing, you want to produce a smart product. That product can tell your customer what is going to happen in the next 24 days, for example. Here is example from electrical vehicle. And each picture is showing the battery healthy of the EV car. So imagine you probably have 100,000 EV you produce for your customer. And you want to give your customer experience when their battery is going to fail. So we can build 1,000, for example, battery models. Since each driver has different behavior, the battery performance for that EV will be different from the standard model, right? So if we just follow a standard prediction curve here, every car will be the same. Every car will be the same. So to make it more realistic, we keep that battery healthy model updated by using our statistic method, and you don't have to worry how to coding that method because we provide a service for you. Your need is just to use that method and plug in your EV car model. So after update, the prediction of that EV battery healthy will be in real time, will align with the real performance of that battery, right? So you get a better prediction of that battery healthy for that EV based on that EV driver's behavior. And the beauty of this framework is you just concentrate on your battery manufacturing, battery model, and you leave all the so-called heavy lift work to AWS. You don't have to worry about how to read data from the sensor. You don't have to worry about how to update the model. You don't have to worry about how to manage the model because probably you have different versions of the model. So your manufacturing just concentrate on your core value and leave all those supporting functions and services to AWS. So that can shorten your development time, that can shorten your deployment time, that can lower your development cost as well. So this is the use case we have done with Siemens Energy. That is in our power plant. They want to predict the corrosion condition of their waste heat recovery boiler. Right? So we create a corrosion prediction model together with the Siemens Energy. But what Siemens Energy cannot do is they don't know how to keep that model continuously updated. They don't want to touch the IT infrastructure because, the domain expert normally has 30 years experience in their domain. And their edge is like mine, 50 plus or even 60 plus. And they don't know how to run TensorFlow, Tensor IoT, all these things. And they don't want to spend time on those infrastructure things. So we support them the infrastructure for the computation power requested. We provide them the framework, how to keep that model updated. And finally, they build the corrosion prediction model running in the real plant. So the benefit of that corrosion prediction, right, can reduce the plant downtime by 60%. It can improve the productivity and the efficiency in maintenance and the field operation. And all of this is running on AWS platform with our L4 digital twin service support. So in a nutshell.
Sorry, Mr. Cheng, the time is up. Time's up.
Okay. So the last one.
Yeah. Okay, sir.
So if you want to go through this digital twin journey, but don't know how to start it, this is a rough timeline. Our team can support your use case by scoping the use case and support the development of the POC with minimum cost. Normally, one POC, if we really want to see a concrete conclusion and the return, will take about 3 to 5 months, depending on how fast we scope. Right. The last one. Yeah, after this meeting, you can contact with our global team here. Everybody here is okay. And also our local team here, Fanli, the pretty lady here. You can talk with any one of them to discuss your digital twin use case. Yeah, thank you. That's all. Sorry for the late.